Hello again. All right, here we are back for another chapter, chapter 3, establishing the context. Interesting concept here for kind of. So let's get on with it. And introduction. Before any risk management activity can be successfully begin, its context must be clearly defined, communicated, and understood. Now, again, what are we going to do here? Key considerations include the context and application of the process, stakeholders involved and affected, what is included and excluded, time limits, and resources. All right, so we need it. Okay. What's the extent of what are we going to do? Are we going to do this on risk management on line one, on the whole plant, on whatever operation, night shift, whatever? Okay. Who's involved? Who's the stakeholders involved in? Who's going to be involved in this thing? Now, who does this affect? That's the stakeholders. All right. How much resource do we need? Do we need to bring in a consultant? Do we do something wrong? Whatever. So it all has to be looked at and figure out, okay, what are we going to need here? Occupational safety and health risk professionals are familiar with the reasons for setting a purpose and scope prior to engaging in formal efforts. Too many times, well-intentioned but ill-defined safety initiatives have morphed into something beyond what was originally understood and agreed upon, causing a misuse of resources and hard feelings. This is sometimes referred to as scope creep. So anyhow, the act of defining the context from which to operate and conduct risk management efforts is found at or near the beginning of the process in the following standards, and I include these standards. Establishing the context, introduction again. Here we are. We're still there, all there. Establishing the context, you can see in our little step ladder here, what do you want to call it? That is like the first thing you got to do. We talked about communication, stuff like that already, and that's very important. But now we're going to get down to this, to actually doing stuff. Establishing the context sets the purpose and scope for risk management process and defines the criteria against which the risks will be assessed. It is especially important that the context be in alignment with and in support of the organization's goals and objectives. For any significant decision to be made, its context must first be defined in the risk-based section, the risk-based decision-making model presented in 3.2, must be defined, period. In the risk-based decision-making model, provides a sequential approach to constructing the decision-making process using risk-based information. Its ultimate purpose is to reduce uncertainty in the organization and achieve better outcomes. So this is your risk-based decision-making. Identify the decision, determine the context, decision makers, stakeholders, options, and influential factors, assess risk, determine needs, select risk assessment tools, generate information, make decision, evaluate information, assess options, select option based on risk, monitor effectiveness, evaluate results, assess impact, make refinements, communicate results. So we're in the beginning part of this. In this chapter, the key elements of context for risk management, external context, internal context, purpose and scope, and risk criteria will be discussed separately. However, it should be considered jointly by the organization when defining an established context. As stated earlier, context and the basic parameters must be defined by the organization upfront in the risk management process. These fundamental parameters include the scope, purpose, scope, and risk criteria necessary to achieve the risk management objective. This generally begins with considering the external environment in which the organization operates. Specifically, the organization must understand the external landscape, influences, interaction, and relationships that affect the organization to properly define parameters of the risk management activity. External environmental factors can include social and cultural settings, external stakeholders, customer, suppliers, public, etc., perceptions, needs, objectives, and relationships, legal and political environment, regulatory aspects, key business drivers, financial influences, economic climate and outlook, potential changes and developments, and other relevant external factors. The internal context, risk management efforts should be in alignment with the internal elements to be relevant and effective. Internal elements would include culture, perceptions, and values, mission, goals, and objectives, strategy, structure, and management style, capabilities, resources, knowledge. What do we have available to us here within our organization? Stakeholders and decision makers, and our internal policies, practices, and protocols. Defining purpose and scope. Setting the purpose, parameters, limits, and scope of a risk management project are critical. Much like a written contractual agreement between parties, a clear scope and purpose statement identifies and describes the specific objectives, limits, and boundaries, resources, and responsibilities of each party. Within an organization's risk management process, the context should define the purpose and scope of the assessment, the responsibilities and accountabilities of stakeholders, the degree or extent of the assessment, the risk assessment methodologies, the risk criteria, and the resources available. Every risk management activity needs a well-defined beginning and end. Managers need to set specific boundaries for the activity with internal resources, knowledge, culture, and values, among others, and external, legal, regulatory, economy, perceptions of external stakeholders, etc., parameters in mind. Specific information to be defined regarding the planned risk management activity should include the type of decisions necessary, the effective business objectives, the expected outcomes, time frame, location, boundaries, limits, inclusions, and exclusions, methods and techniques to be used in the risk assessment, risk management activity. Procurement of required resources, internal and external, including materials, equipment, training, experts, etc. Notice experts in here. As I've said many times, if you're the safety director or manager or whatever you are, don't be afraid to bring in experts. Safety is such a huge undertaking that one person can't know it all. Now you can make pretty good on your OSHA regulations, which you have to be, but sometimes you deal with something like this, you might need somebody else come in, at least for a while, and help you out. When I took over the environmental in California, I had never done anything environmental before. Did some safety stuff, and I still was only a part-time I was doing at the time, part of my job, and not part-time, but part of my job. And so when I had to do some stuff, I had a safety guy come in, and for the first 2 years that I did the environmental reports, he came in and helped me out. And after that, I didn't need him anymore. So I didn't have to hesitate to call somebody in and help me out if I didn't know what I was doing. Specific responsibilities and accountabilities of stakeholders, and documentation and record keeping for the activity. So a sample purpose and scope is given in table 3.1, page 59 of the textbook. So we're not going to look at that now, but you should look at it. Look at that sample on table 3.1, page 59. It's pretty good. Defining risk criteria. As part of the context, an organization must clearly define the risk criteria to evaluate the significance of risks and their level of acceptability to support risk-based decision-making. Without clearly defined and communicated risk criteria, an organization cannot consistently evaluate operational risks or make proper risk-based decisions. Existing risk criteria measures are available in current standards and reference materials. However, it is essential that an organization carefully select and or develop its own risk criteria to reflect its values, goals, industry setting, and overall culture. Guidance on selecting risk criteria is found in all that stuff, and I'm not going to read it. The basis for developing risk criteria consists of determining and defining the key elements to be used, including consequence, likelihood, risk levels, risk acceptability, risk treatments, and combined risks. And each of these elements are briefly discussed in this chapter. Risk criteria should include a mechanism for scoring risk, also called a risk scoring system. So in other words, what are you going to use? A defined levels of risk for specific risk factors include severity of consequence, likelihood of occurrence, and other selected risk factors. What they're doing here, they're establishing, okay, what kind of risk matrix, that's what they're getting at. Defined acceptable risk level and required actions for risk levels. A risk matrix for an organization to measure risk for the purpose of prioritizing and decision-making. Now, again, you're probably not going to want to do your own risk matrix. You can, it's not that big a deal. You can make as many as you want, but do you really need to have more than 5? I don't think so. But if you wanted to get that fine, you could. But I wouldn't suggest it. Why reinvent the wheel? So I would think most of the time a 5x5 risk risk matrix which we're going to use in this course, it would be adequate for most. I can't think of when it wouldn't be, but again, if you want to do something different, knock yourself out. Risk is defined in ANSI Z590.3 as an estimate of the probability, likelihood of a hazard-related incident or exposure occurring and the severity of harm, which should be harm or damage that could result. Therefore, risk criteria must include these two basic risk factors, likelihood and severity. Now, other risk factors may be necessary depending upon the context of the risk assessment and management effort. We'll look into it. Some of these other risk factors may include exposure, frequency, duration, failure detectability, control reliability, and prevention effectiveness. I'm going to talk about each one of these, I believe. The basis for developing risk criteria consists of determining and defining the key elements to be used, including consequences, likelihood, risk levels, risk acceptability, risk treatment, and combined risk. Each of these elements are briefly discussed. Consequences. Based on the context of the risk management initiative, the nature and type of consequences to be included in the assessment, such as human safety and health, environmental protection, business interruption, legal, regulatory compliance, or other consequences, are identified as part of the risk criteria. Now, as safety people, of course, the number one we're thinking about all the time is our employees' safety. I mean, that's just got to be ingrained in you. Likelihood, based on the information and resources available, the way likelihood or probabilities will be expressed in the risk assessment is determined and described. And they're not just likelihood. We'll actually say, yeah, we're going to use likelihood, but how are we going to describe that? And how are we going to define what we're going to use for that criteria? Risk levels, to estimate risk levels in the assessment, a mechanism for scoring risk levels, also known as a risk scoring system, there we go again, in the risk analysis, and methods of measuring and comparing risk levels, risk matrix or graph, and the risk evaluation are determined. A risk matrix is selected to provide a standardized method to categorize risk levels using combinations of the likelihood of an occurrence and the severity of the consequence. Kind of rehashing stuff here, aren't we? Risk acceptability. The acceptable risk level is determined and defined based on the organization's culture, objectives, industry, and legal and regulatory climate, as well as other factors. So in other words, when you do your risk matrix, you come up with a number into red. What are you going to do? Are you going to shut that line down? Well, maybe you will. I mean, if it's that bad. So you have to discern, what are we going to do? How are we going to prioritize these things? And what are we going to use? We're not even prioritizing it. We're just saying, what are we going to do? What is our acceptable risk level? Is it in the green? Is it in the yellow? Risk treatment. Using a hierarchy controls model and the organization's acceptable risk level, decision-making guidelines for risk reduction measures are determined in the risk criteria. So hierarchy controls, heard that before? Well, I hope so. Very important tool. And the organization's acceptable risk level. So decision-making guidelines for risk reduction measures are determined in the risk criteria. Combined risk. Risk criteria should include how combinations of risks will be taken into account. And that's very possible. You could have a combination of risks that's more severity, say, for environmental than it is for people. That's possible. Careful consideration must be given in selecting appropriate risk criteria that will serve the organization's needs within the context, as well as provide the desired results. While being cautious not to place too much emphasis on finding the perfect risk criteria, the occupational safety and health professional should seek to select a method that allows stakeholders to consistently and effectively assess, measure, and achieve acceptable risk levels. There's no such thing as risk-free. We all know that. A certain amount of risk will always be present. Therefore, an organization must determine the level of risk that is acceptable and where risk levels require treatment or control. Residual risks are those remain after treatment. The term acceptable risk level can be defined as a level of risk an organization is willing to knowingly accept or tolerate in its current context. The key word is knowingly, since many times organizations unknowingly have risks that they would not tolerate if it were known by decision makers. Therefore, it is critical that an organization put into practice a risk assessment process with defined risk criteria and acceptable risk levels. The concept of as low as reasonably practicable, or ALARP or ALARP, is defined by the Prevention Through Design standard as the level of risk which can be further lowered only by an increase in resource expenditure that are disproportionate in relation to the resulting decrease in risk. So ALARP is the application of risk reduction within a positive cost-benefit analysis ratio. When a particular risk within an organization is lowered to the point of diminishing returns and it can no longer be effectively reduced, it is considered as low as reasonably practical, or ALARP. Even sometimes OSHA will take that into consideration, and maybe that you might have something that might alleviate this particular risk, but it will be so humongously expensive as it's not reasonable. They will take that into consideration sometimes, but it's got to be reasonable. You just can't say, it's not reasonable because it's going to cost $200. That ain't gonna fly. But you have to have some basis for these decisions. And this is kind of the ALARP thing. Unacceptable risk, immediate action required. At the top of the thing, a 4 down where they got the 4 at. They don't tell you how you arrive at that 4, but operation not permissible except in rare and extraordinary circumstances. Okay, operation not permissible except in rare and extraordinary circumstances. Once you put that in your thing, guess what? Your management's going to want to do. They're going to keep running that line. Operation not permissible. I would rather have that say operation not permissible unless other measures are taken to reduce the risk. In other words, got to do something. One time they're setting up I got a new line in Florida, and it was a pain. Now in fiber processing, it's an art. It's an art. You get the line running, and you can even put it against running great, and you change fibers. You can even put a better fiber in, and it'll do something different. So and they were going crazy. People weren't playing. I kind of felt sorry for them, but there was a particular set of gears moving parts that were kind of dangerous, right? Pretty close to where like a lot of people were. And again, this was just being set up, and they hadn't been made yet. It was being made by offsite. And me and them were going around a little bit on it. I says, no, listen, you got to get a guard on thing. So you know what we did? We made a cardboard guard. And that was fine. I was okay with that. It was temporary. I understand that. Everybody was aware of it, but this was just to prevent accidental contact, and it worked out fine. So there's times when you have to do that. And like I said, it worked out fine. Now we get down to 3. Now they put 2 of these in this middle block. ALARP steps must be taken to reduce risk as low as reasonably practical. That's pretty slushy, but that's what you got to deal with here. If it's a 3 remedial action, did you give it high priority? If it's a 2 remedial actions to be taken at appropriate time. And very low risk, a 1 remedial actions discretionary. Procedures are to be in place to ensure risk levels maintained. Now there's where you get sent when it's discretionary. Now maybe if it's a pretty cheap or easy one, you might do it. If it's going to be pretty expensive, you might lay it or just kind of put it on the back burner for now. Risk scoring systems. A standardized risk measurement system must be established to consistently and effectively assess and manage risks. The fundamental components of a risk scoring system include the organization's defined acceptable risk level and a method of scoring. Risk scoring systems have commonly consisted of a 2-factor calculation using likelihood and occurrence and severity. All right, here we go again. Likelihood and severity. More complex systems using 3 or 4 risk factors are becoming more common, adding a 3rd or 4th risk factor, such as frequency, failure detectability, control effectiveness, or other factors. Risk characterization. To begin, stakeholders should determine whether risk characterization will be qualitative, semi-quantitative, or quantitative in nature. The determination is largely made upon the degree of complexity, available data and resources, as well as the level of detail desired. Qualitative risk models are based on qualitative or subjective descriptions and define risk factor levels using descriptive words, such as high, medium, and low, which are evaluated according to qualitative criteria. And there's an example in this table 3.2. Now this here's you go. What's this? It's a risk matrix. All right. And there you go. There's no numbers on here. They're all just words. Now, I think this is kind of bordering on just semantics. I mean, the color's got to give it away, right? Doesn't matter if it says high in that or 25 in that number. The problem here is like the 2 highs might be the same, or all your 5 highs on this red one but they're not really. If you're going to rank them, you wouldn't rank them all together. So that's what I don't like about this. That's why I like the other one. And they're going to call this a qualitative method. You know what qualitative means? That's something that's determined, like they said, by words like high, medium, low, instead of numbers. Now they're going to call this semi-quantitative because it's not a quantitative. A pure quantitative one will be done on historical data, and you're rarely going to find something like that. So we're going to use qualitative data, cover express risk values with numerical ratings using a formula to produce a risk score. So in other words, here in your top line, the one that's critical would get, or the catastrophic over in the upper right would get ranked higher than the next one over, which says critical, rather than just being left in the same. That's what I kind of like about the numerical one. Risk scoring systems, semi-quantitative numerical ratings, example, table 3.5. And in other words, risk level, this is using a 5x4. And again, I like the 5x5, but your company can do whatever it wants. And again, it's frequent, probable, occasional, moderate, unlikely on your risk level. Unlikelihood. The 5 is going to be almost certain to occur, has occurred more than once in the last 12 months. Conditions exist for it to occur. So it's almost certain to occur if it's frequent. Probable, very likely to occur, has occurred once in the last 12 months. Oh, the top one was more than once. Okay. Conditions often exist for it to occur. Occasional, likely to occur if conditions exist, has occurred within the last 24 months. Conditions can exist for it to occur. Moderate, may occur if conditions exist, has occurred within the last 36 months. Conditions sometimes exist for it to occur. Unlikely to occur, has not occurred within the last 5 years. Conditions rarely exist for it to occur. And then the severity of consequences are catastrophic, one or more fatalities, multiple serious hospitalizations, incident resulting in more than $250,000 damage. Now they're throwing something in here that's not on the 5x5. There's no dollar amount here. Kind of don't like that myself, but you can. So critical, disabling injury or illness, permanent impairment, incident resulting in more than $50,000 damage. Again, I'm not a big fan of the number of things on there. If it's like you want to put going to shut down the line, and okay, I get that would be critical. Marginal, medical treatment or restricted work, recordable incident resulting in more than $1,000. Low, first aid or non-treatment incident resulting in less than $1,000. So again, that's just one person's way of doing it. Risk factors. Risk factors are variables used to measure risk and produce a risk score. Such factors generally consist of severity of harm and likelihood or probability of occurrence. Certain risk models include additional risk factors such as exposure, frequency of exposure, failure detectability, control or prevention effectiveness, vulnerability, or other risk measures. Risk assessment codes, RACs, are used to denote risk factors using initials such as S for severity and L for likelihood. The number of risk factors used in calculating risk can vary from the 2-dimensional severity and likelihood to more complex 3- and 4-dimensional models that include other factors such as exposure, detection of failure, or control liability. Risk factors and their assessment codes used in various 3- and 4-dimensional models include the following: exposure, measure of exposure events per unit. In other words, how many times in a week did this happen? Well, this happened 17 times in a week, whatever. Frequency of exposure, number of exposure events per unit of time. Time duration of exposure, time period that a single exposure occurs. Vulnerability, weakness in the system that are factored into the risk estimation. Detection of failure. I kind of like this one. Estimate of how easily the potential failure could be detected prior to its occurrence. In other words, something that could fail that you'd know about it right away. You could stop something from becoming worse then. But if it's something that could fail, but you don't know it until it gets to be too bad, that could be more serious. Control reliability. So you have a control, but how reliable is the control that you've selected? Now, if the control is an engineering control, it's probably pretty highly reliable. Now, if the control could be an administrative control, and the reliability is going to go down there because now with administrative control. You're changing the way people work, and they don't always work the way you want them to. And they might not have been trained. Training might have not have been sufficient. A lot of things could go wrong with it. Prevention effectiveness, controls effectiveness in preventing a failure from occurring. Risk scoring system. Risk scores are the product of the risk formula selected and are used to evaluate, rank, and prioritize risk for treatment. Its ultimate purpose is to assist in assessing risks so they can be reduced to an acceptable level. Selecting a risk scoring system that works within an organization is more important than which system is selected. Most common is a two-dimensional risk formula, which includes severity and likelihood. The risk factors can be multiplied or added to produce the risk score as shown in the following examples. Again, the 5x5, we take severity times likelihood. So you get from 25 down to 1. You can add them together. Again, you can do anything you want on these things. And then you could throw something, more complex risk assessment models, such as failure mode and effect analysis, include a third factor, such as detection of failure to score risk. For this risk factor, the detection rating is an example of how easily a potential failure can be detected prior to its occurrence. Now, this says prior to its occurrence. In applications where hazard controls are analyzed, a prevention effectiveness factor estimating a control's reliability and effectiveness is used. Risk scores are produced by combining risk factors. When 3 or more risk factors are used, a risk priority number is produced. The following is an example of the 3-dimensional risk formula. Risk number, severity, and now why they did this is multiplication, so it doesn't matter how you multiply these 3 things. Severity times likelihood times prevention effectiveness. Less common and more complex 4-variable scoring systems are sometimes used, which include additional risk factors such as frequency, exposure, vulnerability, or other factors. As indicated by this manual, the use of 3 or 4 risk factors should be used with caution. Multiple factor risk scoring systems can dilute severity of a particular risk if all 4 factors are given equal weight. Severity is significantly diluted in the final score when the other factors are multiplied together, giving each risk factor equal weighting. With a 3-factor equation, each has weighting of 33% of the final risk score shown below. So severity times probability times frequency. Now you could do this. To ensure proper weighting of severity in multiple factor equations, severity should be multiplied with the sums of the remaining risk factors, as shown in the following examples. In other words, severity times likelihood plus exposure, or the severity times likelihood times exposure divided by 2, which would be like the average, the mean of those 2. For hazards that present a potential for high severity and low likelihood, especially fatality and serious injury level risks, a careful review and analysis is advised. This one's, in other words, with high severity, even though they're likelihood, you want to be careful about those because you don't want to underrate them. Upon completing a risk analysis and inputting the risk factors into the risk scoring formula, the resulting risk level or risk priority number is produced. Qualitative risk levels using descriptions can be used. In a semi-quantitative model, numerical values produced in mathematical formulas, such as examples in the preceding section, are often used. And the 5x5 that we're going to use in this, or I use, that's what you're going to get. The resulting risk level, or RPN, is then evaluated and compared to the established risk assessment matrix to determine its ranking and necessary action. Risk screening and communication tools, such as risk matrices, heat maps, graphs, and risk priority numbers, can be used to measure, compare, rank, prioritize, and communicate risk within an organization. These tools provide a measuring stick to help decision makers in selecting and treating risk. For example, 3.4 illustrates a risk heat map that can be used to visually rank and communicate risk. So that's just kind of the same thing in a different way. You mostly see that in the heat index. Maybe that's why they call it heat, or because it looks like it's hot and cold. I don't know really why. But tools used to establish context for safety professionals. The following tools used in establishing context for risk management process are risk criteria selection, Pareto analysis, and risk assessment matrices. And we are going to stop this one right here because this is a pretty long one. I'm going to stop it here because it's about a half an hour into it. And I think that's long enough for any video, give you a chance to absorb this a little bit maybe. And So this will be part one. We'll pick up part two. Well, I'll pick up part two pretty soon, but you can pick it up whenever you want to. In the meantime, be safe.